So I mentioned we would talk about ARP. We saw that in our Wireshark capture. There were some ARPs. That's short for Address Resolution Protocol. What that's going to do is basically translate the IP address to a MAC address of the network adapter. So IP address, at least in IPv4, is a good deal easier to remember than a MAC address. Not so much in IPv6. It'll tell a host where to send the traffic. So basically we call out to the broadcast and say, who has this IP address? And someone will write back and say, I have that IP address. The only problem is that there's no requirement that machines tell the truth. So it is possible to do something called Arp Spoofing. So we've got a little diagram here. So here's my Kali, here's my XP, and here's my Ubuntu. So Kali in the middle. So what we're going to do is tell these machines, in the case like this of the FTP request, we're going to tell both Ubuntu and XP that we are the other one. So they should just talk to each other, but instead they're going to send all their traffic through us on Kali, and we're going to forward the traffic accordingly, so they'll still be able to speak, but we'll be able to see all the traffic. You can also do this against like the network switch, whatever the gateway is, so you can see all traffic going in and out of an environment. The only downside with that is, particularly when you're using a VM like this, you could actually cause a denial of service condition because your machine just may not be able to process all the traffic fast enough, so you'll end up actually slowing down or even bringing down the network in that case. So be careful about doing the gateway, but just against these two systems here, it should be fine. So let's actually look at an example of doing this. Again, these are the slides for the class, so you can see them there. Alright, so let's come back over here to Kali. I've still got my Wireshark running. And open up, let's close this. I'm going to use a tool called Arp Spoof. As we'll see, there's lots of different tools that'll do this automatically, but we'll just do this kind of bit by bit. We're going to start with a tool called Arp Spoof, which, as the name implies, it's built to do ARP spoofing. So the interface we want is ETH0, which we can check that out here, of course. That's our network interface. Arp Spoof -I ETH0. And our target is going to be 192.168.76. And we're going to tell 192.168.76, which is XP, that we are 192.168.1.80, the Ubuntu machine. Before we do that, there's actually one other thing I need to do. I forgot. I mentioned that we do need to make sure that the traffic forwards, because if we do this, sure, the traffic will come to us, but if we don't forward it on to the correct destination, we'll definitely create a denial of service. So what I want to do, if I look at proc sys net IPv4 IP underscore forward, it's currently set to 0. I want to change that value to 1. So that's just going to tell it exactly that we want to forward any extraneous traffic that comes to us to the correct place. So this will keep the traffic moving. Perfect. We can also run ARP and actually see our ARP table right now. It looks like I've actually got a lot of things. Probably when I did that ping sweep and in the first module this happened, it's like it has incomplete next to a lot of things that don't actually have ARP entries. Nothing replied. But let's see if we have anything for 76. Should just talk to it. Yeah, here it is, 76. So that's not ideal that my ARP table is so big, but 000C29853388C. So that should be correct. But if I come over to XP, I should have the same thing. Well, XP will know itself. Let's go over to Ubuntu. And we'll do ARP. ARP-A, maybe. There we go. So it says 76 again, 000C2985338C, and it also knows the gateway. So, and it knows my MacBook, but that's not important. It's not in play. So that we have the correct MAC address there, so for the hardware, so it's just the VMware adapter for XP. So we'll see that that changes when we do the Arp Spoof. Alright, so let's come back over here. And again, so our target here is going to be XP, and we're telling it that we are Ubuntu. Likewise, we need to do it the other way around, so we need to do Arp Spoof. And interface is ETH0 and target is Ubuntu. So just flip our IP addresses around, and we want to tell it we are XP. So you can see that it's basically just sending a ton of unsolicited ARP replies. So when these machines are looking for the correct place to send traffic, it'll get all these replies, which will poison the ARP cache and should change that value. We come back over to Ubuntu, see if it's already changed. It may not change until we actually try and talk to it. So it was for XP 000C 2985 33 8C, so now it's 000C29. So the first parts are the same. That's not surprising though, because the first parts of it are going to be based on the vendor, and it all came from VMware. But then it's 4C7D00. So it looks like it has changed. So now if we do an FTP, I use Georgia and password, do a dir. You can see that creditcards.txt. If I come back over Kali, get my Wireshark, and see all these like retransmissions. That's what all the black is. We're getting stuff that's extraneous. It doesn't belong to us. See, it's like source is 1.76 and destination is 1.80, and we're 1.77, so it's retransmitting it because we did tell it to do the forwarding. So it is doing exactly what we want. So now if we do our FTP, now we see user Georgia, password for Georgia is required, password is password. Now we're logged on. Request for list, so that's our dir. We actually don't see the transfer, do we? It says opening data channel, so that should be FTP data. So what if we do or FTP-data? Here's FTP data, 250 bytes. So this is just going to be a list, not an actual file. But here's the FTP data. Here's creditcards.txt. So what if this person over here decided they would like to get creditcards.txt? It probably, I don't know why I gave it a space, because I'm going to have to escape it. So I download creditcards.txt over here, so if I exit, and if I cat out creditcards.txt, for fake credit card numbers, okay, not that interesting, I realize, but it could be real credit card numbers. But again, I shouldn't be able to see any of that data because I am not the source or the destination. They shouldn't be sending stuff like credit cards in plain text, or usernames and passwords shouldn't be sent in plain text, but, you know, insecure protocol use happens. At least no one else should be able to see the data besides the source and the destination. But if we come back over here, we should be able to see the data. Oops, I'm going to clear that. So FTP or FTP data and apply. So we did our list command, and then here's our file not found because I did it wrong. Opening data channel for file transfer. Here's our 24 bytes. So fake credit card numbers. So if this was like not text, if it was just like hex data, we could just do a hex dump of it, or raw would be the bytes, and we could output it into a file and then decode it somehow or open it in the correct software to parse it. But in this case, it's just a text file, so we can get sensitive data this way. So never send things in plain text. And this is why, because you may be able to say, oh, well, no one else will be able to see it on the Switch network. Well, if something like this, the ARP cache poisoning, is happening, then absolutely someone else will be able to see it. You may or may not be able to do this on your pen tests. I mean, a lot of times they just are too worried about networks going down or being adversely affected. But, I mean, sometimes you may be able to do it. So it's certainly worth knowing how to do, for sure. So let's look at a few more things we can do with our traffic capture now that we've got the basis in place where we're able to capture this traffic. Maybe we can see some other things as well.